Welcome to Module 6 of the Google Cloud Storage course, Encryption. And I'm happy to tell you that by default, encryption is on in Google Cloud, within all of the services. This default behavior uses Google-managed keys. Currently, they're rotated every 90 days, and each key has 20 versions kept stored. That means that by average, you need to re-encrypt data every 2 years. Encryption uses the AES-256 algorithm, mostly in Galois counter mode. This is the best mode to use for high-performance, parallelized reads and writes of encrypted data. Sometimes also cipher blockchaining mode with HMAC or counter mode with HMAC are used. If you're interested in the crypto API used, you can look it up on GitHub. It's called Tink, totally open source. And the specific implementation used in Google Cloud is called the boring crypto module. That module is FIPS 140-2 validated. When you upload data to cloud storage, it gets split up into chunks of up to 2 GB of size. For each chunk, a random 256-bit data encryption key is generated, and the data is encrypted with that key. That data encryption key is then encrypted with a key encryption key, and the encrypted data encryption key is saved next to the actual encrypted data for easy access. Your data actually gets even further encrypted once it is written onto disk. Each disk in Google Cloud Platform has their own unique 256-bit key on the device level. When accessing your encrypted data, the encrypted data encryption key is first read from the storage layer and then moved over to the key management system for decryption. The decrypted data encryption key is then moved back to the storage layer to be used when decrypting the actual data read from storage. Note that the key encryption key that is used to encrypt the data encryption key is never actually available for the end user. It only exists within the key management system. What about the key encryption keys in that key management system? Whenever they're in plain text format, they need to be in memory. Once they are written to disk, they are again re-encrypted, this time by a master key. That master key is then stored in a root key management system. And as you might already guess, those keys, when written to disk, are also again encrypted, this time with a root master key. These root master keys live in a peer-to-peer system in memory only around Google Cloud's infrastructure. If it so happens that all of these root key servers go down simultaneously due to a global outage or something like that, there are also physical backups available in 2 different locations in safes, and only around 20 people hired by Google are able to access those keys. Besides using Google-managed keys, you can also define your own keys to be used for encryption and decryption. The way this works is that you create a key in a key management system and then define that that key is to be used for encrypting the data encryption key for your particular object. This way, when you need to access that object, note that you also will need to have decryption permissions for the key that has been used to encrypt that particular object. When you're using customer-managed keys for encryption, note that any metadata, except for the actual object data, its checksum and its hash value, are to be encrypted using the default Google-managed keys. This is due to the fact that, for example, the object key itself, the name, needs to be available for other services to read. Besides using customer-managed keys, you can just also bring your own key material. This works in such a way that whenever you're accessing the data in Google Cloud Storage, you will, together with the request, send a base64 encoded string of that key material. This key is not saved anywhere, so you will need to take care of its management and safe storage. If you're using this method, then remember to always use HTTPS, as otherwise the key will be sent in plaintext over the wire. Besides using Google Cloud Storage's encryption, you can of course always just encrypt the data on the client side. In this way, Google Cloud Storage doesn't even know that your data has been encrypted, and it will re-encrypt it using the standard Google managed keys anyway. Next, we're going to go and see how this works in practice.